All right, welcome back. We are going to talk about FBDs or free body diagrams today. These are pictures that you're going to use to demonstrate or show what forces are acting on an object. We'll do 1D or 2D, sorry, it'll be 1D free body diagrams today, but we'll be dealing with two-dimensional issues, so like inclined planes and stuff, next time. So again, free body diagrams are a way to draw and show forces that are acting on an object. There are rules for this. So you need to draw your arrows in the direction of the force, the direction that the force is going. You need to draw your arrows from the center of mass of the objects or object. You need to label your forces. And then small lines through force arrows indicate equal forces. So here's some forces to consider. We'll have F sub g is the force due to gravity, F app is the applied force, FF is friction, Fn is the normal force, Ft is tension, and F air is air resistance. So a book is at rest on a table. Let's draw a free body diagram. Here's a book, here's a table. You don't even really need to draw the table. My forces acting on the book, we have F sub g, and we have, oh, that disappeared. You know what? Let's erase this so that I have more space. Here's our book sitting on a table. Forces acting on the book are the gravitational force, Fg, and the normal force, Fn. Typically, if forces are equal, we also draw these arrows the same length, these vector arrows the same length. So they'll expect you to do that on the AP exam, so keep that in mind. Because these vectors, these forces are equal and opposite, they're action-reaction pairs, we would put a little line through each of them to indicate that they're equal and opposite. If you have more than one of these equal and opposite, like say we have forces in another plane, typically you would add two lines so it looks almost like an equal sign like this. Okay? Oop, oop, oop. There we go. Okay, a girl is suspended from a bar which hangs from the ceiling by two ropes. So here's a bar, here are two ropes, and here's the girl doing some sort of somersaulty thing. Oh, she has arms up there. I don't know why I drew more arms. It's okay. She has extra arms. We could all use a little extra in that area. Okay, so we've got tension forces here, and tension we're going to end up learning more about later, but there's tension in this rope. So we've got tension here, so Ft, Ft. We have gravity pulling down on the girl, Fg, and Fg should equal the sum of those tension forces. So that we'll get into again when we do tension. So that one I'm not super worried about you knowing tension, but talk about that later. An egg is falling from a nest in a tree. So we have an egg, got our little eggy. We have gravity pulling down on it. Do we have anything else? Any other forces in this situation? Well, not really. If we have air resistance, then we would have some smaller F air. We'd have some smaller air resistance here, but those two would not be equal unless we're getting into things like terminal velocity. So F air and Fg, and they're not equal and opposite. Then we have an airplane flying at a constant velocity. So you've got your airplane, boop-a-doop, and it's flying at a constant velocity. Okay, if we have constant velocity, that means that forces are balanced. It's super important to remember that. So we'll talk about Fg here. We've got Fg, and then if this plane is flying, let's say it's flying at a steady altitude, then we have some lift force here. We'll just call it F lift. This plane is flying at a constant velocity, which means there have to be two balanced forces here. So all of these forces, oops, those are not double equal, just one equal. So all these forces have to be in balance with their equivalent opposite force, okay? So we have some thrust force here, thrust, and we have drag force back here, or you could call it air resistance. So we have lift, thrust, weight, and drag are the forces that act on an airplane that is moving at a constant velocity. All right, a book is pushed to the right, giving it acceleration. So you would have your applied force, you'd have gravitational force, and you'd have your normal force. And again, gravitation and normal would be equal and opposite. Okay, next example. A book is pushed to the right and has a constant velocity. Well, we have a push, so there's definitely still a right word for force. But if it's moving at a constant velocity, we have balanced forces. Balanced forces, which means that there has to be some equal opposite force going back. And typically in a case like this, it would be our frictional force. Okay, finally, a hockey player glides on frictionless ice at a constant velocity. So we have our hockey player, they're on some frictionless ice, and they're gliding, and they're at constant velocity. We've got Fg, we have F normal, those are equal opposite. So they're moving at a constant velocity. Well, that would mean that you have no forces in the x direction. It's frictionless. Okay, it's frictionless and constant velocity, which means that the sum of the forces has to equal 0. It has to be balanced. Balanced. Okay? Constant velocity has to be 0 net force and balanced. And because it's frictionless, we can't have any force out here, and that means we can't have a force here like an applied force, because that would mean unbalanced. So yeah, the hockey player's moving, but we have no force there. Just because something's moving doesn't mean you have to have a force. So important thing to remember. Okay. Finally, I'll let you guys look at these. They're pretty similar to ones we've already done, but you can go ahead and take a look at them if you would like. I will probably assign some homework. It might be this, it might not be, but that wraps up free body diagrams. So that's just a quick tutorial for you. You have to draw these for your assignments, and you have to be able to draw them on the AP exam. So know them, understand them, and they will help you when we get into more complicated problems as well. They will help you figure out what you're drawing and what needs to happen. Alrighty, that's all I've got for you. We'll see you with the next video where we talk about friction.